we're going to look at finding limits from graphs and then also finding algebraic limits. So first, let's just go over some terminology. If you're looking at a graph and they ask for f of x, okay, they mean the y value of the solid point. Okay, so remember, f of x is just saying a fancy way of saying y. So you're looking for wherever the solid point is and you're reading the y value from that. If there is no solid point, you're going to say f of whatever number is undefined. Okay, so they might ask for a point, or they might ask for a limit at a specific place. Okay, so if they ask for the limit of f of x as x approaches some number, so you're looking at this x value, okay, your answer is going to be the y value where the graph meets. Sometimes they'll indicate a side. So after the number, if there's a little plus sign, they mean the limit from the right. If there's a minus after the number, they mean the limit from the left side. In order for the limit to exist, the graph has to meet at the same point from each side. Okay, so if from the left and from the right meet in different places, you're going to say the limit does not exist. So let's look at some examples. So we want to evaluate the following. So they're going to give you a picture of the graph. So f of 2, okay, this is just a point. This is the solid point. So here's the point at 2. I'm going to read the y value off of the y-axis, and that's going to be my answer. Okay. Now, number 2. This time they want the limit as x approaches 2 from the right side. Okay, so since both of these meet at this same point, this is the right side. So from the right side, the graph ends here. From the left side, the graph also ends here. So this one on the right and the left, since they both meet at this point, both the limit from the right and the limit from the left is going to be the same. So when the limit from the right and the limit from the left, okay, that just means the graphs are connected to the same point at that number. Okay, so at the point at 2, the right side of the graph and the left side of the graph are both connected to this. Like here, they're disconnected. So since from the right and the left they're the same, that means the limit at that point is also 2. So as long as they meet in the same point, the limit from the right, the limit from the left, and the regular limit will all be the same number. But now let's look at f of negative 2. So this one's not a limit, so you're just looking for the solid point. Okay. Well, there is no solid point here, so we're going to say it's undefined. Okay, so if they ask for f of a number and there's no solid point, you put undefined. Okay. Now for 6, 7, and 8, they're asking for the limit. Okay, so we're looking at negative 2 from the right. Okay, so you can see here the graph is disconnected. It's not like it was at 2. Okay, so since they're disconnected, the limit from the right and the limit from the left are going to be different. Okay, so when you're looking at the limit from the right, okay, you're looking at the part of the graph on the right side, which would be this one right here. Okay, so this side would be to the right of the point, this side is to the left of the point. So I'm looking at this point right here, and I'm reading the y value, and it's 2. Now we want the limit from the left. So you're looking at the part of the graph that's connected to like the left side of it, which would be this point right here. So you're always looking at the points at negative 2, and they do not have to be solid points for limits. They only need to be solid points for the regular f of 2, f of negative 2. Okay, so the limits, it can be an open or a closed circle. So for number 7, we're looking at the limit on the left. So that means we're looking at the point on the left of the graph. Okay, so this is the point I say on the right because it's connected to the right portion of the graph. This is the point on the left because it's connected to the portion on the left side. So here, when I look at that y value, it's negative 1. So now for number 8, they just want the regular limit, not from a specific side. So since these two are different, that means the limit doesn't exist. Okay, so if the graph is disconnected and they ask for the limit, but they don't specify a side, that's when you put does not exist. Then this last one, number 9. Okay, this is just the limit as x approaches 0. Okay, so that means they have to meet. So even though they didn't put a point here, we're looking at this point right here. Okay, since both the left part of the graph and the right part of the graph, so I'm looking at the curve on the right side and the left side. Since they are both connected to this point, they both meet here. Okay, that means the limit exists. Both sides are connected to this point. So right here, this y value is 0. So let's look at some more examples. Okay, so we've got a different graph here. We've got g of x. So g of -2. So that's -2. These are where we're looking for the solid points. The ones that don't say limit, you're looking for the solid point. So there's not a solid point here. So we're going to say it's undefined. Now on 11, we're looking at the limit at -2 from the left side. So if I look, both of these points, okay, at -2, the left part of the graph and the right part of the graph, so the section to the left of it and the section to the right of it, they're both connected to this point. Okay, so the limit is going to be the y value of that point, -1. Okay, remember with limits, it doesn't matter whether they're open or closed. So since they're connected, the limit from the left, the limit from the right, and just the regular limit are all going to be equal to -1. Just the y value of this open point right here. Then g of 1, we're looking for the solid point. So that's this one right here. So the y value is -1. Okay. Then we're looking at the limit at 1 from the left, from the right, and just the regular limit. Okay. So the limit has nothing to do with the open circle. It's where the actual parts of the graph meet the point. Okay, so for the limit, we're looking at this point right here. Okay, so at the point at 1, the left section of the graph and this little right part of the section, they're both connected to this point. So they're all going to have the same limit. So if I look at this point, the y value is 2. So the limit from the left, the limit from the right, and the regular limit, they are all going to equal 2. Okay? So the limit's only going to be different when the graph is disconnected, like at this point. So the limit at 3, since these 2 points are disconnected, the limit on the left side and the limit on the right side are going to be different. So for 18, if I look at the limit as it approaches 3 from the right, that means I'm looking at the section of the graph on the right. So we're using this point right here for the limit. So that y value is -1. Okay. Then the limit from the left, so I'm looking at this little section, okay, that's connected to this point. So you're always looking at the points, whether they're open or closed, at 3 for the limit. So since this is on the left side, I'm looking at this point, the one connected to the left portion, okay, and that y value is 1. And so since these are different, because the graph is disconnected, that means the limit at 3, when they don't specify a direction, does not exist. And then for this last one, for g of 3, we're just looking for the solid point, which again was this one right here. I've kind of colored over everything. So this is the solid point. Okay, so that's the only time the solid points matter. Okay, they don't matter for limits. Limits, you're looking for like what the graph is connected to. But for g of 3, this is when we're looking at the solid point. And that y value is going to be 1. Okay. Now the last thing we're going to look at is finding limits algebraically. So that's, instead of giving us a graph, they're going to give us like a function. Okay. So when they tell you what the number is, you're just going to plug it in. So if I plug in -3 for my x's, that'll be -6 plus 1 over -3 minus 1. So that'll be -5 over -4, which is going to give me positive 5/4. So for 23, I'm going to plug in 2. So that'll be the square root of 2 minus 1 over 2 minus 3. So that would be right here a root 1. Square root of 1 is 1. 2 minus 3 is negative 1. So that's going to give us a limit at negative 1. For 24, I'm taking the cube root of 2 times negative 4. So that would be the cube root of negative 8, which will be negative 2. For 25, I'm going to plug in 0. So that'll be 2 minus 3 times 0. So that's just 2. 2 squared is going to give us 4. For 26 and 27, we have some trig limits. So I'm going to plug in, for x, the pi. So that'll be cosine of 3 pi. So that's going to be 0, 1 pi, 2 pi, 3 pi. So it's quadrantal. Okay, cosine, remember, is x. So we're looking at the x value. So this limit here is going to be negative 1. Then for 27, I'm plugging in a 7 pi over 6. So we just need to evaluate sine of 7 pi over 6. So 7 pi over 6, that's in quadrant 3. That's 1 and 1/6. So that's a pi over 6 reference angle, which is 30 degrees. So across from that is the negative 1. The adjacent is going to be the negative root 3, and the hypotenuse will be a 2. So then sine, that's opposite over hypotenuse. So that'll give us a sine value of negative 1/2.